Hello, everyone. Welcome to the AIVC Webinar Smart Materials for Energy Efficient IAQ Management. My name is Menghao Qin from the Technical University of Denmark. Today, we have 6 panelists for this webinar. They are Dr. Jensen Zhang from Syracuse University, USA, and Dr. Zhu-Yun Wang and Mitra Bari from National Research Council, Canada. Dr. Ali Zara Ashra from Aalborg University, Denmark, and Dr. Andong Tran Lei from University of Picardie, Jules Verne from France. This webinar is co-organized by AIVC and IEA EBC Annex 86 project, facilitated by INIVE. This is the schedule for today's webinar. We have 4 scientific presentations. And first is from myself, entitled the Metal Organic Frameworks for Indoor Environment Control. The second one is from Zhu-Yun and Mitra, and about passive removal materials for indoor air improvement, performance evaluation, and modeling. The third presentation is from Ali, and he will talk about the electro-spun fibers for supply air filtration in residential buildings. The last academic presentation is from Andong Tran Lei, and he will talk about the impact of VOC and moisture buffering capacity of bio-based building materials on IAQ and indoor relative humidity, the case of hemp concrete. At the end, we have 15 to 20 minutes of discussion, and Dr. Jensen Zhang from Syracuse University will be the moderator for the discussion. So before the webinar, and I have some practical informations about this system. If you can't hear the webinar sound, and then make sure that the audio connection is on, and by clicking the audio and the video switch audio, then you can pass to your speaker and find the sound. And then the second information is how to ask questions during the webinars. So please use the Q&A box to ask your questions, and do not use the chat box to ask questions, because the chat box is for other communication, and then all the questions could be collected through the Q&A session. Finally, this webinar will be recorded and published at the AIVC website in a few days, along with the presentation slides. So after the end of the webinar, you will be directly redirected to our post-event survey. So your feedback is valuable. So please take some minutes of your time to fill it in. Okay, now we move to the first part of our webinar. Is a welcome and introduction, because today we have many new friends. So I just very briefly give an introduction to the Annex 86 project and the subtask 3 of this project. The title of the Annex 86 is Energy Efficient IAQ Control Strategies in Residential Buildings. The subtask 3, we mainly focus on the smart materials. So the title of subtask 3 is Smart Materials as an IAQ Management Strategy. In this subtask 3, we identify opportunities to use novel materials, from advanced functional nanomaterials to bio-based building materials as building components to actively, passively manage the IAQ, for example, through the active paint, wall boards, or textiles coated with advanced solvents, etc., and quantify their potential based on the assessment framework developed in subtask 1. So this is the general description of the subtask 3. There are 3 main activities in this subtask. First, we will carry out the material, measure the material properties, characterization of the new materials. We will do a literature survey and a laboratory testing to gather relevant data and existing knowledge about the properties for transport, rentation, and absorption of chemical substance and moisture in new functional materials. For example, the metal organic frameworks, MOFs, or photocatalysts, or precise humidity control materials, and hemp concrete as well, etc. The synergetic effect of VOC and moisture on the removal performance of the new materials will be studied. Secondly, we will study the modeling of the behavior under typical residential conditions. We will set up the project will set up model setup, laboratory tests to analyze the performance of these new materials for IAQ control in residential buildings. Because many existing data for these new materials are from the chemistry lab. So the test condition is sometimes completely different from our residential conditions. So the behavior of the materials over time under different climates will be analyzed, and the corresponding control strategies for the IAQ management will be developed. The last activity is assessing the energy saving and exposure reduction potential, because this is a IEA, International Energy Agency project. So started energy saving potential is important. We will, in these activities, we will develop numerical simulations to study the energy saving and exposure reduction potential of the new smart materials in residential buildings under different climate conditions, because we have participants all over the world. So we will test these materials in different climate conditions. The shareholder involved in this subtask it mainly consists of two groups of shareholders. First is the manufacturers of the building materials should be involved regarding testing and the possible co-development of products that have a function to absorb indoor pollutants. Building designers, health organizations, and technical institutions who make testing for the industry and run their labeling systems are also among potential shareholders. There are three deliverables for our subtask. One is a comprehensive review of adsorption, desorption, and transport properties of the smart materials developed in the project for IAQ and moisture control. The second deliverable is about a mechanistic models for estimating the energy saving and exposure reduction potential of the new materials under realistic environmental conditions. The data and the models will be published in scientific journals and a final project report. The last deliverables is a test method for evaluating VOC removal performance of the new materials on the realistic built environment. This will be we will publish some common exercises as a tradition of IEA Annex project. So we will invite all the participants to run and do this common exercise, and then we can collect the results and do a comparison and include in the final report. So far, we have 18 partners or 18 participants from 15 countries around the world, and in our subtask. They are mainly, all the participants can be generally divided into two groups. One is chemists from material science or chemistry. The other one is from the traditional IAQ and ventilation research groups. So this is a very highly multidisciplinary cooperation or interdisciplinary project. We welcome more participants. If you are interested in this project or in this topic, then you can contact me, and then we could, because we are still at the beginning of this project. We just officially started the project in this July. So we are still possible and welcome new participants to the project. That's all for this is a very brief introduction to our subtask and also the main topic of today's webinar.